Hello, everyone, and welcome to the Argonaut Smart Web Messaging presentation. Our speaker today is going to be Carl Anderson. Carl is a senior software engineer with Microsoft and also works with Josh Mandel and Gino Canessa on the software healthcare standards team. Carl, would you like to take us away, sir?
I would. Thank you, Josh. Welcome, everybody. I appreciate your time and your attendance at DevDays. It's been a long week, and I appreciate that you're here to the bitter end. I hear they saved the best for last, right? If you're looking for that, it's Josh Mandel's session. He's going on concurrently with me. But seriously, thank you for being here. I'm honored to be here again. As introduced, I am a senior software engineer at Microsoft. I've been here for about 2 years. For the past year, I've been the project facilitator of the Smart Web Messaging project. I am also the recent author of a Smart Web Messaging client library, which hopefully will be useful for developers who wish to take advantage of this new technology. Before Microsoft, I came from Health Catalyst, and I think I saw them as a sponsor of DevDays this year. So good to see that. With that, let's get this thing started. When I started with the slide deck for this talk, one of the slides that I hadn't originally thought about putting in here was a learning objectives tutorial, but they suggested that it go in. I thought that's a pretty good way to start things out. So we'll talk about what we intend to do during this talk. The first thing is I'd like to make sure that everyone understands what web messaging is and what smart is and what smart web messaging is. They're 3 separate things. And I also want everyone to understand what is this useful for? Like, what problem is this attempting to solve? Let's go.
And Carl, I do apologize for interrupting. You are not sharing your slides right now.
Oh, got it. Let me take a step back then. Thank you for that.
You're welcome.
We're using new conference room equipment, and I'm sure I'm just doing something wrong here. What are you seeing, by the way?
Just your camera at the moment.
Okay. Let me switch to Zoom. Somehow I had it sharing earlier, but somehow I dropped it. Okay, I think this is going to be it. You should see some dunes in a second.
We see them now, yep.
All right, great. Let me get the slides back up. Here we go.
Looks good. Fantastic.
All right. So back to the objectives. I want to make sure that everyone understands what web messaging is, what smart is, and what smart web messaging is, the problem scope. I'm going to show you a live demo. So hopefully we will be favored by the demo gods with good behavior. There'll be some new tools available that I've put together over the past couple of weeks, and quite a bit of new documentation. And also, I want to make sure everyone had a copy of this for your reference later. You'll notice in the lower left corner of every slide, there is a short link. If you visit that link, you will get a copy of this slide deck. So feel free to visit that and make copies, whatever you want. Okay, so we're going to start with smart. Hopefully this is not brand new to anyone here. I'm going to talk a little bit about smart. If you are watching the recording of this, now would be a good time for you to pause this and go and check out the link that I've put in the slide deck. Spend about 20 minutes and familiarize yourself with smart. For those who are on the live call and haven't had a chance to do that, it's a big, ambitious organization. They aim to bring technology to bear in the healthcare space. They do this by encouraging the adoption of standards that will enable ambitiously any developer to write an app and then have that developer have the reasonable expectation that that app can be used across the entire healthcare space. Now that only works with standardization and widespread deployment. And this is not something that is easy to achieve, but the smart organization has had great luck or great results in achieving that. In fact, the 21st Century Cures Act contains language that ties it to smart and smart platforms. So it's not going away. Smart is not just smart on fire. There are lots of different offshoots that are all sort of designed to enable better adoption of technology and integration into healthcare. And smart web messaging is one of those. And we'll see an example of how that happens. So I think for the web developers in the audience, you'll see a lot of familiar things. And for those who aren't web developers, some of this might be confusing. So I'll do my best to step through this in a way that makes sense to everyone and doesn't bore anyone. Let's see if I can switch slides here. Okay. So we've covered briefly SMART, and I would encourage everyone to just sort of revisit that website and just sort of poke around. There's a lot of good history in there. We've covered SMART. Let's talk about web messaging. Web messaging is known by another name. It's cross-document messaging. Cross-document messaging, web messaging, is often synonymous with the HTML5 post message API. This API was developed in order to enable a certain pattern of use inside of a browser that was previously either insecure or difficult. And we'll have an example of what this looks like in a healthcare setting. So hopefully this will make sense and will be relevant to you. Let me actually jump into some of the images of this. So I want you to imagine an EHR, very simple, Spartan EHR that runs inside of a web browser. This is an example of it. The rectangle in the bottom is sort of, it's reserved as a space that a third-party app could be inserted and add functionality and capabilities to the EHR. Now, in this case, it happens to be an iframe, and the web developers here might have their ears prick up and say, well, you know, this is problematic. Having something running in an iframe and communicating with its parent can be difficult. That's what the post message API was designed to do. And Smart Web Messaging standardizes some of the language and the protocols that enable using the post message API in an EHR setting. So imagine this is your EHR and you wanted to embed an app like this. And these apps, we'll see these again later, and you're gonna have to pretend a little bit. These don't actually have any patient relevant details. These are tools that I've developed to test this API. But what we want to do is embed this app inside the iframe and then have them be able to communicate with each other. And this happens through the post message API. So one potential use case is imagine there is an app embedded in an EHR that is aware of the context of the EHR. And when it sees a certain condition, it can make a recommendation to the practitioner and even display a button that says, click this button to visit the patient's family history. And when you're there, look for evidence of X, Y, or Z. So with that situation in mind, this sequence diagram outlines some of the things that would happen in that scenario. So I apologize for anyone who is color challenged, but in the larger rectangle on the left is a blue box that represents a web browser. On the far left edge of that is the actual window object inside the browser for the EHR. On the right side of that blue rectangle is a green rectangle, and that is the app window that's embedded in an iframe. So these are loaded at the same time, potentially coming from different origins. And once they're loaded, they can begin to communicate. So what happens with the embedded iframe, if it is a smart app, it can be smart launched. And when it does that, it goes through an OAuth 2 flow where it communicates with an auth server. And you can see that over on the far right, there's a red column. And that represents the auth server. The OAuth 2 flow happens, and the embedded iframe is returned some launched context. So what that means is the app that's embedded in the iframe has immediate knowledge of who the provider is, who the current patient is, and some other metadata that's needed in order for it to communicate maybe with a Fire server or to do other things in order to have a seamless integration with the EHR. So after the OAuth flow is complete, you'll see the first call to a post message API right in the center of the blue box. This is where the iframe requests to the EHR, I want you to open an activity, say, go visit the family history of this patient and confirm X, Y, and Z. So this post message call is syntactically accurate with what happens with the window object. It's window.postMessage. There is a message payload, which is JSON, a JavaScript object, and a target origin. Now, if you look at the contents that are returned from the smart launch, and hopefully you can all see my cursor, I'm wiggling it around this center part here. There are two properties of that launch context that are important, and they're highlighted there. The first is the smart web messaging handle. That is a string or an identifier that is unique for the user session. It's created by the EHR and provided back to the embedded app so that it can tag that with all of its messages back to the EHR. This is part of a defense in depth strategy, and the motivations for that are spelled out more in the security considerations of the smart web messaging IG. I won't go into it now, but I would encourage you, if you're concerned about security, to check that out. It's a good countermeasure. The other component that's returned is the origin of the EHR itself. Now, this is required for the post-message calls. The browser will confirm that the recipient of the message originated from that origin before it delivers it to the EHR window. So that's how the message is delivered to the EHR window, and you can see that the messaging handle is inserted, the message itself has a unique identifier, and it has a message type. These three things constitute the message envelope, and that's spelled out in the specification document for smart web messaging as well. The message type informs the EHR or the embedded app how to interpret the contents of the payload. So the contents of this payload are omitted, but you can imagine that it would have things like launch activities, the launch activity destination. So like visit family history and any other bits of information that the EHR would need to sort of jump to the right spot. And this is also described in the smart web messaging implementation guide. You can imagine that the EHR displays the family history screen. The clinician goes through and confirms X, Y, and Z, adding information to a Fire server somewhere. At that point, the EHR can respond back to the embedded iframe and say the launch activity is complete. So at that point, the embedded app could then communicate with the Fire server and confirm that it has the missing information. So this is just one example of how an embedded app can influence the EHR if they have a protocol for navigation hinting, for manipulation of shared context, and other things. And we'll get into some other examples in the actual demo of how that works and what that looks like. Okay, so let me go to the next slide. So if you follow this short link, you'll land at the most recent bleeding edge copy of the implementation guide. I think from here you can visit the history and see the published versions. And caveat, at time of recording, we haven't published the first STU1. When we were putting together the client library, we discovered that there was one notable exception that we had forgotten to include, and no one in the ballot cycle had caught it either. So we have to do one minor change, and I expect we'll be requesting publication in the next few weeks. But that should hit the press soon. And I would encourage anyone who's interested so far to take a look at this at some point. But that's what it looks like. Okay, so I'm going to cross my fingers and do some live demos. So I wanted to talk about CVS Hooks briefly and show a little bit of the CVS Hooks sandbox. This may be familiar to some of you who've done any work in the CVS Hooks arena. And I wanted to touch on this a little bit because my involvement with smart web messaging began with the Argonaut 2019 PAMA imaging project that was closely tied with CVS Hooks. In that, we used the sort of undocumented post-message API, well, undocumented smart web messaging design to make some changes to an EHR to satisfy the PAMA imaging use cases that went into law just last year, actually. So we'll take a look at that, and then we'll take a look at some of the new tools that I've put together, and hopefully this will all make sense. So bear with me. I'm going to see if this will actually work. And Josh, let me know if it's not coming through for any reason. Okay, so this is the CVS Hook Sandbox. It is an open source tool that's maintained by developers across several different organizations. I think Cerner and Microsoft both have had an active role in this, Epic as well. And this particular application shows a CVS Hook interface that is intended to be a mock or a pretend EHR. So imagine that I am a provider and I'm sitting in a room with a patient, Daniel Adams, and Daniel Adams has congenital heart failure, and I am getting a treatment plan put together. So I'm going to start by entering a diagnosis. Let's see if I've got it right. Oh, congenital heart disorder. When I entered this diagnosis, a couple things happened under the hood. A CVS Hook that was running in the background has noticed that I have entered a diagnosis that it has something to say about. So this particular CVS Hook is programmed to request that the EHR insert a card into the EHR when a certain condition is met. So it noticed that I entered congenital heart disease, and it wants to suggest that I do something. So there's a couple options here. The first one is I can just insert an MRI into the orders because that is the recommended treatment plan by the ACC. The other option in this card is I can actually launch a smart app, and that app will give me greater control over the state of the shopping cart and some other things. So keep in mind that this diagnosis that I've entered here does not exist on any Fire server anywhere right now. It is only state that exists in the browser. So this is kind of like your Amazon shopping cart as you're putting things together. Although the caveat there is Amazon saves all that to a database. But in the old days, when you're putting a shopping cart together, if your browser closes, you lock your shopping cart. And it's a similar situation in many EHRs today. As you're putting an order together, if you close it and walk away, you have to do it again. So in order to make this information available to a third-party service, you need to have sort of a way for sharing this information securely. And Smart Web Messaging provides provides a way to do that. So I'm going to actually launch this. This app is running in a different tab. You could also imagine it running embedded inside the screen. Functionally, it would behave almost the exact same way. I can make what this is really ugly, but what this is saying is I can modify the request, the actual shopping cart, and then when I update this, it'll insert what I've entered. So one example I could do, I could pick something that is wrong or not optimal. Say I wanted to order a CT scan. Well, CT scans are, there are a lot of radiation, they're expensive, they might be slow to get the patient into. And so there's a good reason to remove this. Now, the CVS Hook allows me to replace it, but I can also do the same thing with the Smart Web Message or the Smart app, change things, and it'll actually apply what I've entered here. I've graffitied the cardiac MRI thing. So anyway, this is just a glimpse of what had been planned in 2019, and we'll take a look at what is available today for the developer experience. Okay, so before I click into this, I'm going to go a couple slides forward and then come back to this. I wanted to introduce some of the components that are available now. So for the EHR developers and EHR representatives in the audience, if you wanted to embed an app into your EHR that would allow you to inject messages into the EHR and then quickly view the response that comes back, you could use this. This is actually hosted on GitHub.io. It's just a static app that runs in GitHub pages. You can embed this into your EHR, and it communicates through post message with the parent window. And then for the app developers in the audience, this is a mock EHR or a demo EHR that you can use to embed your app into an EHR that speaks Smart Web Messaging. So you have an opportunity to take your code, run it here, and then interact with it. You can have it send messages to the EHR, and then you can manipulate the responses before sending them back to your app. So these are the players. And I'm going to skip talking about the library for a moment. Let's actually launch this and see what it looks like. Okay, so I actually intended to have this refuse to connect because I wanted you to see how good I am at fixing problems on the fly here. So here you see the EHR framework. The embedded app area is currently empty, but this EHR framework allows you to configure an app that runs locally. Right now, it's configured to use localhost on port 8001. So if I go to VS Code, I have my GitHub repo right here. I've already actually built and configured this thing and got it ready to run. So I'm going to npm start. and it will run on port 8001. And now this will create a local endpoint that I can reference. So this configuration is still correct. I'm going to close this. Now you see it still says refuse to connect because I haven't reloaded the page. When I reload the page, it will load content and make it available. So now this app is embedded. I can go ahead and do things like insert a message using a bunch of available templates. And these things will be pre-populated with everything that you need to sort of prove that it works. And this is all editable. So if you wanted to, you could provide, custom component or custom parts of the message. So for example, so when I send this, it uses the post message API to send this message using the configured messaging handle, which is right here, to the parent. It's received. And then the mock EHR is smart enough to say, well, I just received a handshake message, so I'm going to generate a suitable response. And if I want, I can send this immediately back. I can click the auto send button if I want to. And then when I get another handshake, it'll automatically flow through. If you're interested in testing your timeouts or something like that, you can use that feature. If you wanted to, you could say, I'm going to send a handshake and respond with something, inappropriate, and make sure that my app knows how to handle, a bogus response, something like that. So this is a glimpse into the available tools. I did want to talk about one other thing. So there's this concept of a scratch pad that I haven't really talked about much. What I've done is I've inserted a scratchpad create message. I'm going to send it. Now, I really need to get better at UX, but for those with really sharp eyes, you'll see that there's a new number up here. It says 1 entries in the scratchpad. If I click on the scratchpad button, it'll show me the contents of the scratchpad. So I'll just reload this and start from scratch. You can see the scratchpad is empty. Now, actually, if I leave this visible, you'll see it update as I do stuff. So scratchpad create, I just sent the message over. It created an object in the scratchpad. And you can kind of think about this like a miniature file server. There's an ID that looks kind of like a location ID of an object, of a resource. And then there's a mapping to an object that has contents that you've requested created. When the EHR does this, it should send back a reply that says, or a response that says, yes, it was created. If you want, you can delete. And I'm going to go ahead and that's right. You request that the location service request /1 be deleted, and the mock EHR says, well, I've got that, so I'm going to go ahead and delete it, and then I'll reply. Now, if I tried to delete it a second time, it also is smart enough to know, well, that wasn't found. So you can sort of use this set of tools to test your code. One other thing is when an app is running embedded, it sometimes does not have a way to signal or to make itself disappear when it's done. So there's another message I want to talk about called UI.done. This is the way that an app signals to its parent, it's okay to delete me from the DOM. Go ahead and take me out of the interface. So in the mock EHR, when this message is delivered, you get a pop-up that says, it's going to close in a couple seconds. And the way it's implemented, it just sort of empties the contents of the iframe. It's up to the EHR to do whatever they want. They could actually remove the iframe, and then you wouldn't see any rectangle at all, or do something completely different. But for the testing purposes, I've left it like this, so you can actually reload it once that's done. Okay, so I think we've covered some of the new tools that are available. Jump back over these things. And please visit the links if you want to check this out live. Oh, there's also a user guide with each one of these things I wanted to talk about. If any of the instructions or details wasn't covered in the talk, it's all in the documentation. Okay. Go on to the next one. Okay, and then the other thing is the actual messaging that takes place. I've written an NPM module that you can import in your JavaScript that makes it a lot easier to do this sort of thing. It provides the mechanics so that a unique identifier is generated when you send a message, and then if you respond to a message, it pulls out the unique ID and sets that in the appropriate response field, and it helps you develop asynchronous JavaScript code, so you can do things like send a message and then wait for the response to come back using the promise API. So that's also available in NPM. And here's some other links to the user guides that I've put together. And let me see, how are we doing on time? We're not bad. Let's see. So to recap, what we learned is that smart web messaging is part of Smart. It helps enable applications to embed seamlessly into an EHR, and they can take part in the Smart Launch framework to get some of the metadata that they need to get to hit the ground running and create a seamless experience. You've learned where the tools are that I've provided. There's plenty more other resources out there. The CVS Hook Sandbox is not the only sandbox out there. I know there are 3 or 4. Let's see, what else was there? You can find me for the remainder of DevDays. There's not much of it left. But you can feel free to reach out to me anytime. I'm also on Zulip chat. I'm usually paying attention to the Smart stream. And I think we can open up for questions. Hopefully I didn't butcher anything too terribly.
And Carl, while Jeremy opens up the mics for people to actually ask questions, there are 2 in the Whova Q&A. Would you like me to read those off for you?
Oh, yes, please.
Okay, fantastic. So the first one is, do you associate a procedure set with the allowed disorders?
I'm assuming this question was probably asked around the time I was showing off the CVS Hooks Sandbox. I think, and please re-ask the question if I'm missing this, but I think the intent is the app can have complicated logic and make complicated decisions or recommendations based on the available information in the EHR. You can really sort of offload some of the complexity into these embedded apps. The ability to make recommendations to do things like to launch an activity or to make changes to the scratchpad is the limiting part. There has to be sort of coordination between the EHR on the other side, so that when a payload is delivered in the scratchpad, it knows how to interpret it and take appropriate actions in the UI.
So this is Gay. I asked the question. Can you hear me?
Yes. Okay.
Okay. So I actually was, when this was started a couple years ago, I was involved in it a little bit, this project. But so what I'm thinking of is if you're, and maybe the app is just a facilitator that then people can, add to it to make it sufficient. But let's say I'm a clinician, I'm using your app, and I want to order, a particular procedure. And I've started that ordering procedure, and you at some point you showed sort of a place where you could search for conditions, allowed conditions, I think, or conditions.
Yes.
Right. So can that be a short list? So, if I've picked, MRI type A, would I then only be shown the allowed conditions for MRI type A?
Right. Yeah. So I think it depends on where some of this stuff takes place. So in the example I showed in the CVS Hook sandbox, there was a list of available treatments, and they were not contextually aware of the diagnosis. That just happens to be the pre-canned available things for that demo. If you had real estate in your EHR available for an app, it could make really intelligent suggestions based on the conditions that are available to the app. And it can get some of those through the Fire server if it has permission to do that, or it can get it from the EHR context. So if the clinician has entered something into the EHR, the app can request it from the scratch pad. And as long as the EHR has put it there, it will be available for it to make recommendations.
Yeah, to me, that's the real value of something like this, is that you save clinician time by, they avoid claims being rejected and all this kind of stuff if they're only already in advance ordering or providing justification for,
Yeah, and I think you shouldn't underestimate the savings in context switching just between looking at one screen versus another. Having the ability to embed logic in the EHR on the same screen just saves cognitive load.
Yeah. Thank you.
Yeah.
Carl, we do have one more question here.
Sure.
How is smart web messaging adopted from the major EHRs, Epic, Cerner, and their sandboxes?
I don't know about the sandboxes. I feel like the sandboxes are a little bit behind. And in fairness, this is a spec that has just been brought to the point of being ready for publication. That being said, Cerner and Epic and other EHR developers have been active in the balloting of this IG, and they're very aware of the opportunities for enabling this. So I think that everyone is on board, and if the sandboxes aren't ready yet, I think they will be soon. But I think the demo code that I've provided is more than enough for interested developers to get started on this.
All right, fantastic. We have one more that came in. If the embedded app wants to update data in the EHR, a patient, would web messaging be the way to communicate this, or a put to some API?
Yeah, it's a good question. I think web messaging is really necessary to manipulate things that are ephemeral. So if you think about the shopping cart, web messaging is a great way to update that stuff because it doesn't necessarily exist in any Fire server. With that being said, a lot of smart launched apps also have access to the Fire server and can, in some cases, make direct changes that way. So I think it sort of depends. I think it's helpful to remember that smart web messaging was designed with the ephemeral state in mind. But I think depending on how things evolve over the next year, it could go either way. And this is an ongoing conversation. There's been a lot of discussions about smart web messaging where the resolution has been simply, well, let's encourage developers to experiment and report back. And so we'll see more smart web messaging tracks in connectathons, and we'll see this topic come up more and more in fire infrastructure calls, and as issues are brought into JIRA, we'll see them discussed by the major groups, the infrastructure groups.
Fantastic. There is one more that just came in, and we have just about 5 minutes left. If you're wanting to ask a question, you can do it in Whova. The next question is, where is the line between this and Firecast, or is Firecast still a thing?
Firecast is still a thing. And it's a good question. I think Firecast, I'm not an expert on the technical details, but I think Firecast requires a server to be set up to handle the session synchronization or the state synchronization. With smart web messaging, this is all possible to be done statically. So once the app and the EHR have been loaded in the browser, there's nothing else needed. The components can just communicate with each other, and it's, I'd say, lighter weight. But yeah, I would also encourage people to ask this question in Firechat in Zula.
All right, fantastic. I see there's one more question here, and then I see Gino has his hand up.
I was
Gino,
just going to comment on the Firecast thing. One of the big differences is that smart web messaging is within a web browser.
Yeah.
And Firecast can be in multiple applications. So if you have things like DICOM workstation or a transcription system or things like that that are not web-based, smart web messaging can't work. If everything you're doing is within the browser like that, then this can fit a lot of the same use cases.
All right, fantastic. The next question is, can SWM be a communication layer between different smart apps, i.e. between a structured data capture app and other app providing terminology services?
I'm trying to imagine the scenario where that would unfold. I think that the way it's designed, a smart app, when it's launched and embedded in an iframe, it can communicate with its parent. I think technically you could use the post message API to try and send messages to other iframes, and I could be wrong about that, but I don't think that's in the design use case. Now, maybe you could have an EHR that is willing to relay messages between apps that are both visible on the screen at the same time, but I think that's sort of outside of the realm of where this was designed.
All right. At this time, I am not seeing any more questions here, Carl. Did you have anything else you wanted to follow up with?
No, thanks for attending, and looking forward to hearing from all y'all.
Fantastic. Thanks so much, Carl, for that fantastic presentation on Argonaut Smart Web Messaging, and thank you all for attending. This will conclude the presentation. Thanks so much.
Thanks.